Thank you very much, Dylan, and we thank you for giving us the opportunity to tell our story. Today's agenda, what we'll do is review a little bit of the evolution of load balancing at Dartmouth, and then talk about how we adapted to embrace a new architecture using HAProxy One. And then we'll discuss a little bit about our automation of load balancer deployment, give a quick demonstration, and then talk about some of the successes, lessons learned, and critical success factors. For those of you who don't know or aren't familiar with Dartmouth, the college was founded in 1769 in Hanover, New Hampshire. It's the smallest of the Ivy League schools, and it has a long storied history, and as a result, it's a place that's very much steeped in tradition. But we have evolved, and we now have the college built its reputation on providing an outstanding undergraduate liberal arts education, and now it's been evolving to include some professional schools, and as Dylan mentioned, research institutes. So load balancing at Dartmouth. Our team, Kevin and I, and our colleague, Andrew Johnson, who's the project lead for the HAProxy migration, are a team who supports the load balancer platform. But in addition, we serve on other platform teams as well. And our job is to provide for whether it be for load balancing or whether it be for any other of our platforms, to provide a reliable, innovative, and agile solution. Our clients are, for the load balancing platform, are about 50 users who are software engineers, software developers, or other IT specialists scattered either within our infrastructure group or across our enterprise and business services groups. Also, they reside in our Dartmouth library system, Geisel School of Medicine, Thayer School of Engineering, and Tuck School of Business. Our history, as I look at it here, is very much the same timeline with regards to load balancing as HAProxy, maybe within a year. We first implemented a solution which I'm not sure was entirely load balancing, but it was content service switching in 2002. And it wasn't a couple years later when we moved to a hardware-based platform, F5, LTM, and GTM, and we stayed on that platform for a pretty good long time. And so it wasn't until 2018 when we moved to more of a software load balancing solution. And that's where we have been since. That AVI network solution obviously has seen some changes. In 2019, VMware acquired AVI Networks, and subsequent to that, more recently, Broadcom's acquired VMware. And so in basically September of 2024, we find ourselves taking a look at the alternatives and pursuing a migration to HAProxy.
So I'll talk a little bit about load balancing at Dartmouth. We implemented that in 2018. What that allowed our clients to do was to describe the load balancing service they needed, using our specification, commit that to our configuration repo, and deploy that with Jenkins on demand so that they didn't need to wait on infrastructure. Also allowing us to limit their access to the GUI. So they could get into the control plane GUI for monitoring, but we didn't want them in there causing configuration drift and such. Some fun facts here. We have about 1,100 deployed load balancer manifests in our repo. And though this varies widely from business cycle to business cycle, and during the academic year, we have about 10 commits per week in our repo. So yeah, here we are at changing times. A couple of motivations: rising license costs without apparent value, and declining vendor support subsequent to acquisition after acquisition. Some of the goals we had were to maintain our current LBAS implementation, of course. We wanted to use our existing structured data to make the migration seamless for our clients and, of course, reduce costs, maintain high availability, and a key here is to build a strong vendor partnership with our vendors to keep our innovation going. So the way forward, we started a project. You can see our requirements here. Probably one of the highlights is the separation of the control plane and data plane with an API-first model. Kubernetes service discovery is important for us as well. We interviewed top vendors. Of course, HAProxy was in that list, and did our demonstrations, interviews, and such, and HAProxy came out on top, particularly with the top-notch support model, which we would come to appreciate as we worked out our infrastructure implementation, which we'll talk about now. Obviously, here are some of the key features we just wanted to deploy. Fusion control plane. We're going to use IPAM, GSLB, VRRP, and custom log formats. Here's a representation of our synchronized data plane. These are some of the key services that are running on these synchronized by Fusion, and their corresponding config files also managed by Fusion. For GSLB, we have a delegated subdomain, and these are our two resolvers that are configured in our campus DNS for resolving load balance services, you can see with the lb-dev domain name. Here's a little snippet of our GSLB config, and you'll notice this is a map file that we are using until we have some native functionality in Fusion to manage this. We put our config in the map file, which is then pushed out to the control plane. We have a script on the control plane that tracks that file and updates it and restarts GSLB when there are changes pushed. We have 2 IP addresses associated with each front end. You can see the answer list section here, including those two records. And then we specify round robin for the answer list for each front end. Here's an example of what a client sees when resolving. We have separated our data plane into 2 VLANs, one for public-facing services, one for private. You can see we've further separated that. This is where we track the static IP addresses that are on the data plane interfaces. And here's where we track the ones that are assigned to VRRP for the front-end binds. Here's an example of our IP assignments in IPAM. As I mentioned before, 2 IP addresses for each front end. And we've leveraged the very helpful comment field to document the GSLB that's using it and where it's configured in VRRP. We have 4 VRRP instances, 2 for load balance traffic and 2 dedicated to GSLB because of its importance. Yeah. And so here we've got our 2 active VRRPs. What we wanted was to have a load balancing of the load balanced traffic. So under normal circumstances, we have 2 data plane nodes round robining data plane traffic. You can see here our failover order allows us to lose O1, shift to O2, O3 or O2, and then so forth. So we get down to 1 data plane node, at which point we're probably looking at a disaster recovery situation. Dave's going to take it and talk about the automation.
Yeah, so in terms of implementing some automation, that's actually going to create all of that. What we're starting off with, even prior to migrating to HAProxy, is about 1,100 or a little over 1,100 of these configuration manifests, and each one has a standard set of configuration parameters that either are required or optional, and people have created these and copied each other's syntax, specified various settings, and then leveraged a number of optional parameters. Here's a few of them here, not all of them. Largely the syntax here is platform-agnostic. Some of the terminology was specified originally when we went to Avi, and dates back to 2018. One of the challenges that we had that we face in any kind of migration, so this isn't our first migration, and with Avi, what we faced was the challenge of having to try and implement in automation every option that a user would need. And we had to put a bar at some point and cut off rarely used functionality. So one of the goals we had in this migration was to see if we could at least improve the amount of automation dealing with what we have currently as manual configuration, and turn that into a more robust manifest that can be used by a wider audience. In our Git repo, we've got a YAML configuration manifest format that our users can use. So this is their document that they can go consult, in addition to existing templates that they can go check out. And this contains a lot of settings that we've created, or a combination of settings that we've created for common use cases. So we'll try and support those common use cases with a single parameter setting, rather than requiring a user to set everything up, and then it gets a little bit more complicated for them and cumbersome for them to use through the automation. So we do, in cases where customization is necessary on their part, they can specify more comprehensive settings of configurations. And so what ends up driving this for us is, just as we did with Avi, we have a master Ansible playbook that ultimately we're using. And it deals directly with Fusion, which we love. So this is going to sync the changes to the data plane. And so it authenticates with an API key. It parses the manifest. And then basically it goes out and acquires the IP addresses, the bind IPs that Kevin was talking about. And then it goes through and it assigns those bind IPs. Actually, it determines which NIC on the host is going to be used, that IP address will be used on, and then it assigns those IPs to the VRPs. And then we found this useful. It renders front-end and back-end configuration, which copies, so that we can track that. Because inevitably there are some times when we're like, wait a second, we thought it was this way, and now it seems to be behaving differently, and we can track those changes. But ultimately, the goal is to load all the JSON structures that we'll then be able to use Ansible for to load into Fusion and have that configuration pushed out. The master playbook also calls some storage playbooks and some of these calls are optional depending on the configuration parameters that a user specified. We'll have a situation maybe where the user specified an IP list, allow or deny lists, and so then we'll call a storage playbook for that. Same thing for things like user agents. And we've also got a scenario where we have a commonly shared front end, which does a lot of back end switching. And so that's very useful for us in public IP situations where common configurations can share the same front end, and then we use back end switching on that front end to direct traffic. We also call a storage playbook to update that GSLB map file that Kevin was saying with the record and the answer list. And then what we're doing is initiating transactions, storage transaction for map files, configuration transaction for front and back ends, and then also, but not shown here, VRP transactions. And you can see those. So we started off trying to adapt our Avi automation to work with HAProxy. And we actually had a version of that we got off the ground. But very quickly, as we started to try and implement some of those manual configurations in our automation, we realized that refactoring that automation was super cumbersome. And so we started taking a look at ways we could do things differently that would expedite our ability to introduce a new configuration parameter in our manifest. And so ultimately what we settled on was organizing these front-end and back-end Jinja 2 templates into sections based on the standard stuff that you'd find in a front-end or back-end. And so we've got the main section. The default server section will have information about monitors, SSL, SNI, ACL section, back-end switching rules. All of these are organized this way in our front end and back end. And then what we do is we leverage a couple of, like resource type and calling template. And what this does is it modularizes our code. So all of a sudden now what we can do is introduce a new parameter by simply dropping a Jinja 2 template into a Git repo and then exposing it in these front end and back end Jinja 2 templates, and all of a sudden our parameters live. And this was really useful, even as recently as last week, when people are doing testing in our non-prod environments that have been migrated already to HAProxy, and somebody says, I can't, my front end's not operating correctly, and I just don't understand why this setting is this way. We discovered it was a manually set parameter in Avi, and there was no automation for it. And so we said, we can easily just create a new template here, a few lines of code, drop it into whatever sections are relevant here, or drop it into all the sections, and then the template is only invoked when it's relevant. And so you can kind of see the other sections there. Ultimately, the front end and back end Jinja 2 templates in our environment call what I'll call functionality templates. So like this is the area where we had, you'll see on the screen here, we had a specific monitor in Avi was called System HTTP, and it's got all these settings in it. And the user had specified monitor : system HTTP in their YAML manifest. And so it was easier for us to basically figure out what those parameters are in Avi, adapt the Jinja 2 template for that, drop it into the monitors template here, expose it in the back end or wherever, and it's immediately goes live. So that modular nature really kind of has helped us implement new features. The other thing that's great is we don't have to touch the actual Ansible code. Like now that we've gotten all the configurations and the transactional stuff taken care of, and Fusion takes care of all of that for us, the playbook just stays and we just use it. And so all we do is a little Jinja 2 to enhance the functionality. One critical factor in our solution is something that we stumbled upon. So let's see, we got our Slack channel in early September, and I think November 4th, I reached out to the HAProxy folks and said, does anybody have it? Like, we're struggling to call APIs, all over the place. And, it seems like, I feel like we might be reinventing the wheel. Like, is there something that you have or you've seen customers use that we could leverage to expedite our efforts? And Jacob replied back and said, well, maybe you should check out this thing, Fusion Control Plane. It's this Ansible collection. So we get this zip file and we download it and we start looking at it, and it does exactly what we want, sure enough. And shout out to Mark Boddington, who maintains this, wrote it and uses it a lot. And he's been super helpful with allowing us and customizing this a little bit more to expose functionality that allows us to abstract the Fusion API calls one level from our Ansible playbook. So, for example, we don't use WAF in Avi, so we're not going to use WAF at go live in HAProxy, but we will. So eventually we'll get around to saying, all right, well, now we need to have some WAF parameters. We'll expose those. We'll make modifications to the Jinja 2 templates. And then what we'll need to do is add an additional playbook that will take care of the WAF transactions. This collection really expedites that. Instead of making API calls and doing a lot of management on our own, we could just invoke these roles and the functionality is immediately available to us. So it's very valuable. So ultimately what this all does for us is it abstracts the happy configuration. Our users are doing the same thing that they've been doing. They're specifying, whatever parameters, or in some cases, this manifest may have been sitting around for a year or so, and no one's really touched it, and no one wants to touch it because it's got to stay up. So we're abstracting that, and we're turning that into the front end, the back end. We may be creating some map files. So here's an IP list map file. Here's a user agent map file. And ultimately what we end up with is that good old front end, back end configuration in Fusion. And that's exactly what we want. And so one of the things that we're also doing is obviously we've got we can track changes in Jenkins, which is where we're launching this playbook from. And obviously in Git, we can see changes, but we are not allowing our users to have anything other than read access in Fusion, with the exception of updating certs. And what we do is we leverage the description field here to allow us to track when that front end or back end was last touched. And I think eventually we'll add the capability to see who last touched it. And so teams of people are responsible for some of these manifests. And so, for them, they've never had the capability to say, all right, when was the last config change for this? And when did this happen? And so that having the ability to track all that information is very valuable to us. So we just have like a real brief demonstration here of our load balancer in action. And so in this demonstration, we'll see how one of our users at Dartmouth might leverage our load balancer as a service automation to make a configuration change to a running load balancer. In this hypothetical scenario, the user would already have been granted access to a Git repository environment called IS Load Balancer Configuration. The Git repository contains a YAML manifest for each load balancer that's been deployed in our load balancer environment. It also includes documentation that contains a list of all the allowable parameters that can be specified in the configuration manifest. We saw that earlier. In this document, our users can see whether or not each parameter is required, as well as which template, HTTP or TCP, supports the usage of a particular parameter. Where appropriate, we've got comments that provide our users with additional guidance on parameter usage, and there's also a date tracking field so they can see when features are exposed. As you can see, some of the parameters accept one set of predetermined values, while others can take either a single value or be further customized by using a more detailed specification. And in this example here, we have a monitor specification that will allow a user to specify a path or a URL, as well as acceptable HTTP response codes and a successful response string. Our documentation contains examples of using such specifications. Let's take a look at the configuration parameters that would be required to control a firewall setting in the load balancer. And here you can see that there are two parameters allowed in the configuration manifest. The firewall parameter can be used to specify one or more IP addresses or a CIDR, while the firewall mode parameter can be used to allow traffic or deny traffic from IP addresses. So here's an example manifest that's been deployed in our load balancer environment, canary.dartmouth.edu. Saw it earlier in the example. And as you can see from its configuration, canary.dartmouth.edu has been configured to bind on private front-end IP addresses and is handling incoming HTTP traffic, terminating SSL for 2 back-end pool members listening on port 80. You can see how those backend pool members are being monitored using the health check URI and are being marked up if they return 200 or 300 response codes and a successful health check response string of health check working in this case. Farther down in the configuration, we can see the firewall parameters that we reviewed earlier. Note that traffic's only allowed to reach the backend pool members from a single IP address. We can test that configuration, that firewall setup, by navigating a browser to canary.dartmouth.edu. Looking back at the configuration, we can explain the behavior observed in the web browser by noting that an outage action was specified to redirect traffic to outage.dartmouth.edu. The redirect occurred because the browser's browser's IP address was not in the allow list of the firewall setting in that configuration manifest. So let's make a configuration change to the manifest to allow traffic from my browser's IP address. And then what we'll do is commit that change to our repository and save the changes and then push them. Next, we'll launch Jenkins, just like our user would, and use the HAProxy deploy config pipeline. This is our dev version of it in that case. And we'll build with parameters and submit canary.dartmouth.edu.yaml. And that manifest will then be fed to the pipeline, ingested, and hopefully our configuration is deployed to HAProxy. Just sped up for time here. And so now that the configuration's been applied, if we go back and check our web browser to see if the IP address is now allowed, we can see that it's now working. And so as you can see from this simple demonstration, we've completely abstracted all of our load balancer implementation details from the process that our clients use for deployment. Some of our users don't yet maybe understand what a front end is or a back end, nor do they understand what ACLs are or map files, and arguably should they. Their procedure for deploying a configuration at HAProxy has remained exactly the same as it was when they were deploying their manifests to the Avi load balancer.
So in conclusion, we can highlight some of our successes. The new automation fully supports the existing load balancer manifest, which means that our users don't have to change a thing. Multiple new features we expose through automation. Some of them are listed here. The key thing, particularly as Dave mentioned earlier about refactoring the way we are using templates, is that it allows us to be responsive when users want new features implemented, and that helps us ward off requests for admin rights in the control plane. We're prepared to fully go live with a simple switch of a CNAME. So we switch the service in our campus DNS to the new delegated subdomain, and that service is live in HAProxy.
So lessons learned for us. We had to get all 1,100 load balancer manifests deployed well in advance of go live so that we're done. We haven't gone live in prod, so we're sort of straddled right now. Non-prod is all migrated and maybe a few production things that have self-selected to go live, but the remaining prod configuration is still in Avi. But we're ready and we're done, and so it's a CNAME switch at this point. So it was really important for us to get all of those things deployed well in advance so that we could confirm all those configurations are syntactically valid and they'll actually result in the configuration in HAProxy that we intended for that to get translated into. And it also validates all of the manifest features that were existing, plus the new ones that we exposed. And so we've been able to be prepared for a scenario where early adopters are like, yeah, I'd like to go now instead of going live when the go live is, So that's very handy. It's also been great to have the production environment ready for the purposes of training our power users on how to work with the Fusion GUI. I mean, it looks like it will look when they go live. Our whole model is predicated upon the idea that we're operating the new load balancer side by side, HAProxy sitting side by side with ALB, and that affords us that simple and quick migration strategy. It provides us with a simple failback and quick failback option in the event that there are problems encountered. And it also accommodates our ability to say, there's this additional scenario, manual configuration that we really didn't test adequately, or the users whose manifest it was didn't test adequately, and we discover an issue. In which case now we've got a side-by-side comparison that we can perform and try and rapidly deploy a new parameter change in HAProxy and fix the problem, and then go live with that service as well. Critical success factors. That HAProxy Slack channel is impressive. I'll use the word unparalleled. I'd say remarkable, but that people use that all the time in different contexts. But the Slack channel is just unparalleled. It's been amazing to feel as we're trying to learn these technologies, because as I said, Kevin and I are responsible for other platforms and not just load balancing. And so the amount of time we get to spend with this particular platform is not such that we can just be the masters of everything. We've got to sort of learn it, spin it up, go live, and be able to rely on it. And having that wealth of expertise is absolutely invaluable. Shout out to an amazingly patient and knowledgeable support team, Nathan Werriman and Mark Boddington and the rest of the team, Jacob. I could name everybody, but it's just been amazing. So thank you so much. Having, for us, a critical success factor was having regularly scheduled check-ins. We didn't always need them, but it was just really great to say, all right, we've got these 3 punch list issues that we really need to get answered sooner rather than later, and we knew exactly when we could expect to be able to chat with somebody. So that really helped out a lot. And finally, engaging our power users early in the project was so critical. Trust is just, once you have it, you don't want to squander it. And the critical period in this process is really kind of the ramp up to go live. So, we got that early trust and we got that buy-in, and people are using HAProxy and they're in the Fusion GUI and they're saying, oh, this looks great. This is much better than what we used to have. That's the kind of feedback we want to hear. And so, and then finally, having the ability for important services to get tested way earlier, so that we have time to sort of treat those more like pets than cattle, and ensure that their go live success. So I guess before we end, I'll harken back to Kelsey's analogy with the Tetris blocks. And when I think about that, I think some of that applies to our environment, because I feel like what we've done is limit the number of Tetris shapes that our users need to work with. I mean, can you imagine what it would be like if there was 20 different Tetris shapes and you had to try and fit that together? And I feel like that could have been the case. In this case, it wasn't. And so now they can get busy figuring out how to connect these blocks together in ways that they can create new solutions. And HAProxy was the key to being able to provide that. So thank you.
Thank you.
Gentlemen, amazing. That was a lot of breadth covered. And actually the first question in the stream was, is there any feature you don't use?
Is there any feature we don't use? Well, I said WAF. There is some features we don't use, but we want to. So yesterday,
That was the follow-on when do you plan to?
Yeah, so the security control plane is very intriguing, and we're doing like elementary stuff with regards to blocking and allowing and things like that. If we could give the power of that technology to our users by exposing a few simple parameters that we can kind of scope down into a single or a few blocks for them, that's harnessing power.
Yeah,
Yep.
that in the UI that lets them understand what's going wrong with their application, who's attacking it, from where.
That's right.
I love the Tetris callback analogy. That was clever. A question about you talked about Slack. A lot of folks, probably everyone uses Slack in some capacity. We do have the HAProxy community Slack, which is the one that you were talking about. That
we got a customer support Slack channel.
Yep.
Yeah,
So directly with the
support.
HAProxy technologies team.
We wouldn't be on the timeline that we're on without that. We would be months away from going live.
Another one in the stream, is the manifest so far restricted to what Avi used to do? You converted every Avi capability to HAProxy capability without issue?
No.
So our new manifest or new version of the manifest is now fully supporting every configuration that we used to have in Avi. Some of those were manual, so now those are all implemented in our manifests, and we've exposed new parameters already in HAProxy only. So what's nice, this is a single Git repo, and we've got another Jenkins pipeline that goes against Avi. So what we do is we just sort of track the changes, keep them in sync. As Kevin said, the volume of changes is such that we can afford to do that. But what we don't have to worry about is we introduce this new parameter in the manifest. Avi doesn't know what to do with that parameter, but who cares? Because the Avi automation and its Ginger 2 templates don't read that parameter, so it's not a problem.
This is an RBAC question. How do you use Fusion to limit access for some users to read only, and how much flexibility do you have in setting user access permissions?
Right. Well, as we mentioned earlier, our users have read-only access, so they can see all the metrics and stats. They can even use that for troubleshooting. But if they want to deploy changes, they're going to do that through deployments to the pipeline.
Hey guys, great job. You must have had an excellent sales rep that you worked with in the evaluation process.
Yes.
So what was the thing that swayed your decision within the evaluation process to work with HAProxy versus the alternatives?
Probably the responsiveness to our questions, less grandiose marketing in the initial conversations. And we wanted something on-prem as well. You want to add anything?
I would agree with Kevin. It felt like we didn't get like this massive team that showed up to like try and show us all these features that we weren't going to necessarily use. And what you did was listen to us and allow us to express our use case, and then you assured us that what you provide is not vaporware, and you actually helped close those gaps between our knowledge and what you do. And that's so important because there's always that 20% that you just don't know about. and I think you reduced our blind spots substantially.
Or that stuff that works on paper but doesn't work when you try to implement it.
Right.
Excellent. Well, gentlemen, thank you so much. Everyone, again, give it up for Kurt and Kevin.